So thanks for coming to my talk. My name is Craig Chamberlain, and this talk is called Hunting Cloud Supply Chain Threats Using Anomaly Detection. Um, my, I have a long version of my biography, my introduction, but the short version I can give you is what happened is 20 years ago, I was picked by a security product startup in the Boston area, and we got to MVP. We had a purpose-built rule detection language like many security products do, and the next question was, well, what should it actually detect? Like, what should it detect? What should it alert? What should it do? And nobody wanted to work on that for various reasons. So I thought it was interesting that we could do anything, but we didn't know what it should do. So I volunteered. I kind of said YOLO and volunteered to work on that. And then went on to work on several more large-scale threat hunting and detection products and projects over the course of my life, and still doing it today. And this is a talk about, as far as, this is my second time at BSides San Francisco. Well, it's my second talk here at BSidesSF. My talk last year was given by a colleague because I wasn't able to be here, unfortunately. This is actually I think my seventh BSides talk now, because I was at BSides Rochester in March. And I've done a bunch of other conferences. I've done 14 or 15 conferences. Lots of publications, basically just been working on threat detection for most of my life. How I got here is 6-7 years ago, I was doing work for some of the largest cloud using organizations in the Boston area where I'm from, and got interested in threat hunting and detection there and how different it was. Along the way, I kind of went on a walkabout in 2018, and I did a project. I did a detection project in some open source tooling just for fun. Started doing work on practical applications of machine learning for threat hunting and detection in 2019. That was the subject of my talk last year. And so continuing to work on applications of machine learning and anomaly detection for threat hunting in general, cloud threat hunting and detection in particular, as well as the combination of new technologies like machine learning with conventional detection. The approach that I like to take, and I'm going to turn this into probably a blog post or try to flesh this out and try to articulate this more, but the approach that I think we need to take, or that I would like to take in this problem space, is to kind of define a new discipline. And the reason being is because not many of the existing disciplines that we have in detection engineering are not exactly what we need in the cloud world. So network security monitoring, endpoint detection and response obviously are, absolutely foundational, essential, pivotal tools and technologies that we need. But there are large areas of cloud detection where they're just not that effective, because a lot of the cloud API activity just simply doesn't leave host or network evidence. The reason I don't call it data science, and I don't plan to become a traditional, conventional a data scientist, is when it comes to threat detection, not everything is a data science problem. If you can detect there are some threats we can, even in this space, there are some classes of threats we can detect with simple conventional searches and rules and queries. And if we can detect a threat at such a low cost as that, then that's preferable to spending enormous time and effort on a machine learning approach. In other cases, there are areas where we really need complex machine learning or anomaly detection tools in order to find some of these things. But not everything is what we call detection engineering problem in this world. Not everything is a data science problem. So what we really need is to kind of merge the two of those. So what I'm going to show here today is, I'm going to show you what I've been doing over the past year or so. Is I've been continuing to do work on anomaly detection for cloud threat hunting and cloud threat detection. And I want to show you some examples of kind of articulate how I'm doing that in some detail, and then show you some of the most interesting examples of what I found so far. One of which is, and the reason I wrote this talk is, the first time I turned on this particular detection stack and tool set that we're going to see here today, the first time I turned it on production data, I found something that I wasn't expecting. I was expecting to find possibly some credentialed access and some more of what I'd been seeing. I wasn't expecting to find what I found, which is something kind of new and interesting. And so I'll show you what that looks like in great detail. So the reason for the Ocean's 11 theme in this talk is, if you've seen my talks, a lot of them have movie themes. My mom was a huge movie buff when I was a kid, so I grew up as a child going to the movies. So I guess that's what happened here. But the reason for this particular theme is, what struck me is that it wasn't that long ago that supply chain attacks were kind of beyond our imagination. And why I say that is, if we go back more than a decade ago, say into the 2007, 8, and 9 time period, I can remember sitting in threat modeling sessions in large financial institutions with large, talented, very capable security teams. But when it came to third-party or supply chain scenarios, it was simply beyond our imagination at that time. And one of the remarks, somebody in a meeting once made a remark and said, "Isn't that something like an Ocean's 11 scenario?" And at the time, it was something we hadn't yet conceived of. Of course, a decade later, now we've seen, in fact, just recently now, we have possibly the largest, most interesting example unfolding right now with 3CX, where it appears that there were actually 2 supply chain attacks in that intrusion set. The earliest one is probably 2013 in Target, where there was apparently an HVAC vendor or a third party that was compromised that had access to the network. That was the nature of the supply chain there, or the supply chain intrusion there. Of course, in 2020 we had Sunburst, which was probably prior to this year, probably the largest. I guess it remains to be seen. It's an open question as to whether Sunburst or 3CX has the highest cost or impact in the long term. The RSA breach, I include that because that wasn't exactly a supply chain attack, because as far as I know, none of the software product there was actually poisoned or anything. I think it was more strategic in that the ultimate objective there was probably not the manufacturer of the 2-factor tokens. It was probably one of the users. So we've seen supply chain attacks now with a network management product, with a voice over IP product. Probably see more of them over the course of the decade. But what about one area I think we haven't really thought about yet is in the cloud arena? Because if you're a cloud user, or if you work with large-scale cloud users, one of the things I've noticed over just the last few years is that there are an increasing number of third parties that have some or sometimes a lot of access to their customers' cloud accounts in order to deliver services. Sometimes they're security services, sometimes they're just management and orchestration services, but they're delivering services. And so sometimes they have access to prod accounts, and sometimes they have a lot of access. And cloud threat hunting and detection it's hard enough that we've seen there are more than 4 examples out in the public record, but there are 4 large public record examples and case studies that were big enough that they actually went to prosecution. So we can go and read the indictments and read about them in great detail. And the thing that's interesting is that in the case studies that I'm going to show you, I don't think that the common thread is anything to do with the organizations who experience these, because some of these organizations have very large, very capable, very talented security teams, as you'll probably realize when you see the names. And I would venture to guess that many of them were probably doing, not everything 100% right, but they're probably doing a lot of things right when it came to security, and they probably did have sophisticated detection tooling. But in these 4 cases, there was large-scale exfil that simply went undetected until it was far along, and it was not detected early enough. And part of the reason is that most of what we're dealing with most of the time is, not always, but most of the time we're dealing with credentialed access, where credentials have been compromised and somebody is persisting via credentialed access and impersonating a legitimate user. And that tends to look like, that starts to look like insider threat hunting, which is something that I had worked on earlier in my career. And it's one of the harder things to hunt, I think. If you look, the biggest examples of this possibly are, well, there was actually there's another example just recently where there was an Air Force employee who released some classified material into a Discord server. And so now there's a large debate about, well, how did this happen and why did this happen and how is this detected? But it's the second or third time that we've seen this, and I think the answer is it's not that something wasn't done that should have been done. At least I doubt that's the case. I think it's more a case that somebody who is technically literate and is very familiar with the systems that they are exfiltrating data from, and possibly even familiar with what detection mechanisms exist and how they might evade detection. Hunting an insider like that who has any degree of sophistication and knowledge of the terrain is a very difficult thing to successfully hunt and find. And so when we have smart, sophisticated threat actors who have obtained credentialed access in cloud accounts, sometimes it's hard to distinguish them from ordinary users. So this is the best one-sentence version of the problem statement that I've found so far. This actually came from a blog post from a blog related to one of the incidents. This is a better problem statement than anything that I've come up with in the past few years. It's simply that the problem is that at the end of the day, sometimes it's very hard to differentiate or disambiguate between threat actor activity and legitimate user activity, because we're looking at credentialed access, and the difference between legitimate and suspicious activity is sometimes it's a matter of nuance. So working backwards through there are four big examples. There are four examples at least that were large enough to go, well, three of these have gone to prosecution. The fourth remains to be seen. But most recently in 2023, we saw a case of credentialed access. This one was kind of interesting because according to what was published, apparently there was a developer laptop that was running a service that was internet facing, and their laptop, and so somebody was able to get execution and persistence on this laptop, and then from there we're able to obtain credentials to access to not only access cloud data, but to access some particularly sensitive cloud data and to exfiltrate the data that they were after. And this is a hard one. This might be the hardest one of them all, because this might not have, even if you were scrutinizing activity at the time this happened, this might not have looked very different from that user's ordinary work behavior day to day. The exfiltration, of course, if you had been able to see the exfiltration, that's a possibility. But apart from that, so in 2021, we had this case where, according to the indictment, we had an actual case of insider threat, the first big insider threat case that I'm aware of so far, at least, in the cloud environments, where, according to the indictment, a user with some privilege went rogue and started to exfil data, and apparently tried to engage in some kind of an extortion scheme or some kind of a monetary demand in exchange for the data. Eventually, law enforcement were able to identify them and get attribution, and it went to prosecution. One of the things I've noticed about these indictments, and the reason that I put them in here, is that many of these indictments have a kind of a breadcrumb trail to anomaly detections, or kinds of anomaly detections and potential anomaly detection recipes that we can use. Like in this case, they mention in the indictment, that this user ran a command called get caller identity in the course of, so the user logged out, came back in from a VPN in order to try to hide their identity or obfuscate their identity, and then ran get caller identity. And get caller identity is basically like a who am I command. And it's very unremarkable to see a user or a program running that command. It's pretty unremarkable for the most part. So I'm not surprised that this wasn't, if people were looking at the logs on this day, there wasn't really a reason somebody would have found that unusual. There's one possibility though in each of these. So in each of these examples, there's one possibility. Something else that they mentioned that might have been anomalous was they changed retention policies on certain storage, probably on an S3 bucket, or certain storage places where logs were kept, probably as a defense evasion, probably thinking that if they changed the retention to 1 day, then with only 24 hours of log data, by the time anybody get around to investigate, there might simply not be any log data to investigate. In 2019, we had this case where, and this one was a bit more complex, where somebody was able to, according to what we know, somebody was able to actually kind of bounce through a WAF or web application firewall service and get execution on the virtual instance running the WAF, and then call the metadata service. The metadata service, if you're not familiar, it's just an informational service that exists in most cloud environments where a virtual machine or a compute instance can call the metadata service over HTTP and just ask questions about itself. And it can also ask questions like, what am I authorized to do? And if I'm authorized to do this or that transaction or work in this service or that, can I have credentials and authorization to work in those services? And the metadata service will say, yes, you can, and you know, use these credentials, use these temporary access tokens. Long story short, somebody was able to obtain access tokens this way, and we're able to use those to start exfiltrating bulk data from the storage service. And you notice that this was the example that kind of originally got me started thinking along these lines, because you notice in here, they even note, and they probably weren't thinking about anomaly detection here. I don't know if they were, but you know, they actually comment on the fact that this WAF role would have been a role that was used by this virtual machine instance in order to deliver WAF related services. And they notice that this WAF role doesn't ordinarily invoke the list buckets command. List buckets is, if you're not familiar, it's basically like an LS. It's like it's like an LS for a storage service. It's like list available, not directories, but a bucket is not exactly like a directory, but a bucket is a container where files and data blobs can live. So it's basically like, show me a listing of available storage units. And then 2016 was the first one of the more interesting ones, because in this case, they, according to the indictment, according to what we read, they actually shared snapshots from the victim account to the attacker account. And a snapshot is, in cloud speak, what a snapshot is essentially a virtual disk image. It's just an image of a virtual disk. It's normally attached to a virtual machine, but it can also exist in a detached state in order to be attached to some other virtual machine. But you know, it will basically contain the file system that whatever virtual machine uses it expects to have, which may contain production data and of you know, any and all kinds. And so they use this sharing feature to sort of forklift data to their account, and presumably from their account they exfiltrated to somewhere else that was under their control. But this is another case where let's look at these. So if we look at these actions, each one of these in cloud speak, when you call an API method, it's in some clouds it's called an action, but essentially you're calling an API method. And so can we, when it comes to the question of how do we detect these things, well, many of these that we're looking at are not really good candidates for simple alerting or detection. Why? Because they're just supernumerary. So get caller identity is sort of like, who am I? And as you can imagine, you could have similar issues alerting on that you might have alerting on who am I in a heavily automated environment where that's used extensively. But that can, in production, I'm looking at CloudTrail data here, which is what I've been focused on, but get caller identity may exist. There may be hundreds of thousands of instances of that action in the logs at any given time. List buckets is usually in the tens of thousands, and shared snapshot volume created can range. It can be a few thousand, but it can also get up into the hundreds of thousands. Anybody know why? That's something that has been on the increase over the last last few years. The reason is because snapshots are increasingly being used by security products and services, so for so-called like agentless security scanning. So sometimes security tools will, in order to avoid having to install and manage agents, sometimes security tools will scan the snapshots instead. And so snapshot access and snapshot operations have become much more supernumerary than they used to be, say 5-7 years ago. So then when it comes to user context, this is just a simple scatter plot to give you an idea of what it looks like. But there are, and this is what a lot of these look like, in that there are a small number of user contexts that call this action a huge number of times, but then there's a long tail of user contexts that call it occasionally. And too many to think about any kind of simple alerting. Same thing with source IP addresses. There's a few source IP addresses that call that action a large number of times, but there's a long tail of source IPs that call it occasionally, with a long tail of normal outliers. Too many to potentially too many to make that a good candidate for anomaly detection. So list buckets is one of them, is also a heavily used command, and it normally occurs thousands of times a day. It can occur millions of times a day if it's an environment that makes heavy use of S3 as its primary data layer. Typically, you'll see it if you on any given day in any given CloudTrail log set, you'll see at least 50,000. You'll see up to 50,000 unique user contexts calling that method over the course of, not in a day, but over the course of most of the retention windows that I'm dealing with are between 1 and 4 weeks. So in a matter of weeks. So the problem is, how would you find in that second example, when this one role associated with a WAF service that has no reason to call list buckets starts calling it? The data was there, but it might be one user context amongst tens of thousands. So when it comes to detection, the snapshot sharing method actually has a tactic technique combination in the attack matrix, and it's called, well, there are several related to snapshot sharing and modification. And I think the one we're looking for in particular is at the bottom is called snapshot modification. But there's a tactic technique called transfer data to cloud account, which essentially involves using snapshots to exfiltrate data. And so the guidance here talks about, says, periodically baseline snapshots to identify malicious modifications or additions. And I think that's good advice. The practical problem is how to implement that when we have tens of thousands or maybe hundreds of thousands of snapshot operations with a long tail of normal outliers in most dimensions, whether it's user context or source IP or something else. Source IP address, we can pretty much take that off the table as far as looking for unusual source IPs, because for one, in most cloud environments, there's an incredibly large and unusually distributed number of source IPs. There's too many to even start thinking about baselining or doing anomaly detection. There are normal outliers. There are new IPs that show up that you've never seen before, and they're used for a time and they go away simply because source IPs are considered to be you can't consider them as an entity, in that you can't assume that there is a user or a host or any kind of an entity behind a source IP, because things come up and down and IPs are assigned and unassigned. And so that's not really good fertile ground for conventional detection or for anomaly detection. So even though we're looking at volumes like these, there are cases, and there actually are projects where people have written alert rules they've written simple alert rules for actions like these, like assume role. Assume role is basically almost like the equivalent of a sudo. It's saying, I want to assume role, I want to elevate or change my privilege from who I am now to this other role. Why? Because this other role will allow me to do work in another service or elevate privileges to do something I want to do. A get secret value is pretty much what it sounds like. Assume role with SAML is when you have human users logging into the console. Most of the time, if they're logging into the console, they're authenticating via SAML. And there are fewer of those than there are just plain old assume role events. The reason being because assume role events are used more by compute instances than by humans, for the most part. They're heavily used by compute instances in order to assume the privileges that they need in order to do work. And so, with these kinds of numbers, it's way too many of these to think about simple alerting. But even if we wanted to start creating complex logic to try to baseline these, the amount of branching logic that we would need to try to define and enumerate normal versus abnormal use of some of these methods based on users or sources or something else, it's just too large to deal with. So the good news is that the threat model that we're dealing with, for the most part, even though the possible manifestations are numerous, and if we draw an attack tree like I've tried to do here, it's, at least for credentialed access, it's relatively simple in that most of the time we're really looking for either a compromised compute instance. So somebody has persistence on a compromised virtual machine or container, and then they're doing assume roles calls from there in order to elevate privileges and gain access to data or things, or somebody has compromised credentials and they're authenticating using a key. So they've obtained a key from the file system on a compute instance possibly, or they've obtained a working set of credentials from somewhere else. And so what I've done is, in order to try to explain why I use some of these anomaly detection methods, I've organized them here into these two different branches of this tree. So in the case of compromised credentials, what I've found is geographic anomalies work pretty well for this. And that's not new. So geographic anomalies are good at detecting a lot of authenticated credentialed access and a lot of anomalous credentialed access patterns. But they're also really useful here because most of the time there isn't a lot of normal variance in source geography for cloud activity, especially automated cloud activity and transactions. So rare service for a user and rare source geography for an action are what they sound like. So rare service for a user is a user working in a service that they normally don't. And the reason is that most users, most of the time, they work in the same services over and over again, and they generate very dense amounts of transactions in the logs. It's relatively unusual for a user to start using a new service and to generate a very sparse number of transactions. Usually users and user contexts, usually they generate very dense activity or none at all. A new action for user is, I'm using that instead of rare action for user, and I'll show you why. Spikes and errors and events are useful, and in the next chart, I've got another diagram where I'm trying to illustrate what each of these, like why we use in which case each of these does better or worse at finding particular parts of the threat model tree. So on the compromised instance side, the odds are with a compromised instance, it's going to be running, there's not going to be any kind of geographic anomaly there for the most part. But there often will be rare service activity. There often will be new transaction activity, possibly new roles for a key. What that means is that there was a new combination of, in an assume role event, there was a new combination of key and role name. The reason is that because most of the time, because a key can be assumed, well, most of the time we can assume that a key has an entity behind it. It's either a user or a compute instance. And whether it's a user or compute instance, they tend to use the same roles and do the same work over and over again. So when you see a new combination of user context and key, or a new combination of key and user context or role, that's often interesting. That can be an indicator of possibly privilege elevation or lateral movement if it's a case of credentialed access. So this is kind of like my attempt to diagram what each of these anomaly detection methods are good at finding. So on the horizontal axis, so the horizontal axis is the duration in time. Did the intrusion just start 5 minutes ago? Or has it been going on for a day? Or has it been going on for a week? Or has it been longer than that? So is it a short or long duration? And the horizontal axis is the density of the events. Is the intrusion set, or is the intrusion or the threat actor creating many events and doing many transactions and creating many events, or is the density small? And so this is the reason why I find I need the combination of different functions. The three main functions I'm doing are new, things that are new, or combinations that are new, and that they have not manifested before, things that are statistically rare, that they are the least frequently occurring combinations in certain combination sets. And then the spike function looks for, they look for rates of events or errors that are unusually high. Say, like, if you take the 5 largest spikes in an error or an event by standard deviation, and if you take the top 5 from the entire set, you often find that the top 5 to 10 are outliers in that they are well beyond any kind of normal peaks and troughs you see from day to day. And so a spike in error like that can mean, doesn't necessarily mean that there is an intrusion. A spike in errors can also mean that something is just broken, or something, possibly something third party is trying to do, is trying to elevate privileges that it doesn't have, and something is just misconfigured. But there's the interesting thing about the interesting thing about a spike in errors is that there's not really a benign explanation for a spike in errors. It's either something is broken or there's something suspicious going on. So in the case of something that is relatively new, say just started recently, new functions, say like a new action for a user or a new combination of key and role, will often be good at finding that. But if the intrusion is extant and it's been going on for some time, maybe some days or weeks, then most of the time a new function won't necessarily find that. So in that case, a rare function, looking at rare combinations, is better at finding that, assuming that what they're doing is assuming that there are aspects of what they're doing that create kind of sparse events or sparse combinations. Geographic anomaly detection is good generally. Of course, there's but it's not a panacea. But of course, there's a simple evasion for geographic anomaly detection, which simply is, don't be in a different geography than your victim. Make sure you're in the same geography that the victim is in which case we have to start thinking about things like autonomous system network names, which is something I want to do next, because even if you're in the same geography as your victim, the odds are your AS name and number is probably different. And then spike in errors and events, like I said, a spike in errors is a good way of finding if somebody lands on a compromised instance and starts doing large-scale enumeration in order to do privilege elevation or lateral movement, or just starts doing discovery. It's often the case that they'll create a huge spike in errors that's well beyond, could have a standard deviation into the tens of thousands. It's well beyond anything you've seen before. Unless they land on an instance that has, say, godlike access, that is unrestricted admin access, in which case they may not generate any authorization errors, but they may well still generate an unusually large spike in certain events, especially discovery events. So in the examples, the practical application for this in the examples is, in the first case, the get caller identity transaction was coming in from some kind of a VPN service that likely was in a source geography that was unusual, possibly new, not seen before, but probably rare. But even if not, if it was, say, if the geography was unremarkable, then there's still a case for an rare or new autonomous system network name. In the case of where the lifecycle retention policies were modified, this would be a job for something like a rare source country for an action, rare service for a user. Odds are that most of the time, most human users don't go around setting lifecycle retention policies to 1 day, especially for logging. Logging is usually set up and torn down by automation. So this might have been a rare service for a user. It might have been a new action for a user. In this case, this was coming in from, and some of this, from what I read, was coming in from a VPN. Some of it was coming in via Tor. So there would have been a rare source geography for these actions. There would have been a rare service for the user as this user context started calling S3 for the first time. And if we were running at the moment this happened, there would have been a new action for the user, and that we would have seen this user context call list buckets for the first time. And then the snapshot activity We don't actually know enough about this to know if there was a rare source geography here, but I suspect there likely was. And if not, there's likely a rare source network. But there would have been a rare service for the user and a new action for a user, because from what I've read about this, from what I understand, the user context in question here was more of a business user, not an engineer, and not somebody that you would ordinarily see sharing snapshots. So it would have been very anomalous. So the reason I'm not doing, say, rare action or method for a user is because there are too many normal outliers. It looks like this. And I've tried this, running combinations of rare action meaning method, basically rare transaction for a user in CloudTrail data. And it will find suspicious activity and threat activity, but it will also find normal outliers that are just not remarkable. So the signal to noise there, it's good, but it's not great. Like in this case, if I were to run this, what I'm doing at the moment, I'm actually doing anomaly detection in SQL at the moment, because I have my CloudTrail data is in a series of SQL tables. And it turns out there's some math functions you can do in SQL. So when we tried running rare action for a user on a medium-sized cluster with, say, 300 million-ish events, there are 200 to 250 results typically. And some of those are interesting enough to investigate, but many of them are not. So the signal to noise is just not good enough to think about turning that into an alert or turning that into something that goes into a unit of work. But if we run new action for user instead, the way to define that is, what I mean is that looking for, in the set of transactions that have been called by a user, looking for instances in the last 1 to 2 days where I have a combination of user and action that has not manifested in the prior, say, 30 days, using a query. And so using a query, I'm limited to going back to however much hot table exists in the data, or exists in the table, sorry. In the future, I plan to turn this into an Airflow pipeline so that it will have some memory, so that it will be able to reason about new combinations that it has seen, like new combinations in the last day or two that have never been seen before for as long as the function is running. Even though we only maybe have 1 or 3 days of hot data, it still remembers what it has seen, basically for all time. So a simple learning function. So the first time I turned this on, what I found is this, and it was not what I was expecting. So this is the output of one of the queries called rare source country for an action, and it's essentially looking for the least frequently occurring instance combinations of event name or action, basically the transaction name, and the source geography, because in this case, I'm enriching these events with geographic data, which is something that I don't think that happens automatically in most cloud environments, but it's something you can do. There's geographic data available from providers like MaxMind that you can use to do this. So, does anyone notice anything right off the bat? In the first row, there are 2 assume role events from a source country, and then there's another describe instances event. Describe instances event is what it sounds like. If you call describe instances with no arguments, and then it'll basically just return, say, here's everything we know about all of the instances, the compute instances running in this account. Basically just tell me everything about the compute instances. It's very unusual to see a user call assume role twice, or it's very unusual to see assume role happen twice in any dimension, whether it's user, network, source IP, source country, or anything else, and same for describe instances. So it turned out, it didn't take long to find out that this was a source country that did not have any business relationship, and so this activity was inexplicable at first. There were also a couple of start and stop instances events, which were a little troubling because what those do is a start instance will start a virtual machine. A stop instance will stop a virtual machine. The reason it's troubling to see that in combination is sometimes you'll see that combination if a virtual machine has been modified in order to, because if you don't have, say, if you're a threat actor and if you don't have working credentials to persist into a cloud API, but if you do have the ability to modify a virtual machine, sometimes people will choose to persist in a virtual machine instead, and then attempt to elevate privileges by means of whatever assume role operations the virtual machine can do. But to see, again, to see one instance of these two transactions from any dimension, whether it's user, country, or source IP, or anything else, it's very unusual. And most of the time, most user contexts are doing very dense, very large numbers of start and stop instance operations. It's very unusual to see anything or anyone just do one of each. And then this was new action for a user. So it turned out that the describe instances transaction was also something that this user context had never called before. And so this has been a little bit, some of this has been grayed out. But what I found is it was actually a third-party account that was being used to deliver services in the environment. So the presence of this third-party account was normal, but the transactions that were doing were not and could not be reconciled. So this was investigated, and in the end, it was decided to completely remove this access. In terms of hunting for this, I tried to include some more helpful information in terms of considering whether or not there may be unauthorized third-party activity going on in a cloud account. One of the good places to look is if you have a spike in errors, if you have a spike in authorization errors related to this, then they'll often give you some clues about, well, they'll definitely tell you the user context that's behind it. And then that's one way to, if you sort these out by user context, it's one way to kind of quickly determine whether or not you have suspicious activity coming in from any kind of third-party delegation accounts. And then in terms of the question of when you're looking at data like this and you're asking, well, what is this third-party account actually supposed to do? One of the things you can do is if you can go back to find the original create policy events from when the access was first instantiated, the create policy events will usually when the vendor is setting up their access, they'll do a create policy operation, and that create policy operation will usually tell you what it is they expect to do. So that's one good kind of clue, is that if you find a third-party account running into errors or trying to do something that you can't reconcile, and if it's not something that is specified in the original create policy, then chances are that it could be that something has changed on their side, and they haven't thought to ask for increased permissions or access, or it could be that something strange is going on. And in terms of, do I have any third-party access at all? It's actually not that easy and straightforward to kind of audit for this. But one of the things you can look for is, depending on how far back your data goes, is if you do, sometimes you'll find this event called create OpenID connect provider. And this is just a sample request and response. And if you have third-party access, you'll often find, or if you're about to have third-party access, you'll often find that this is one of the events associated with setting that up. Couple other examples. There's actually two things going on here. So the first line item is PACU, and that's actually authorized security audit activity. Somebody's running a PACU is essentially like a security testing framework auditing tool. It can also be used for pen testing. But the third line item is not normal. And what it's outputting there is that user account authenticated from two different countries at the same time. So at the same time period, they were authenticated from two different countries. And one of the countries is one that simply doesn't make sense because there isn't any kind of business relationship. Planning on using, so as far as expanding this, I'm thinking about new country for a user and possibly new source IP for an account. And the reason being is that, again, if an intrusion has been going on for more than a short time, then sometimes, sometimes it'll be easier to find this, sometimes it won't. But if you're in a situation where you have these functions running continuously, like in this scenario I described, where the new functions have been running for a long time, and they're able to remember, basically, they're able to remember a long-term baseline, then we potentially could pick up a geographic anomaly, potentially pick up a credentialed access instance coming in from an anomalous country right away, like in the first few minutes, versus having to wait for a geographic anomaly to form. New source IP for an account, what that's about is if you interrogate your cloud inventory data and keep track of all the IP addresses that are in use in your account, there's a lot of really useful things we can do with those to reason about. Like one is that if we see authenticated activity coming in from a cloud provider IP address and it's not in use by one of your accounts or by one of your instances, and it means it's from somebody else's account. So either it's an account we don't know about or it's something strange going on. Plan on doing similar things with endpoint data. One thing I find useful is if you have network events from virtual machine endpoints, you can correlate those with the network inventory in order to look for sort of north-south traffic where virtual machine instances are doing heavy network activity outside of your AWS account. Now, it's not always that abnormal for them to be going outside of your AWS account because odds are they're going out to the internet to do lots of work. But if they're going to, say, an AWS or an Azure IP address that's not one of yours, and the activity is dense and it's authenticated maybe, or if it's something that you can't reconcile an endpoint, like if it's a Netcat instance or maybe SCP or something else that doesn't make sense, and it's doing heavy activity to another cloud account, then it's hard to think of a benign explanation for that. So that's a good detection. This was an example of a new action for a user. This is the best thing it's done so far. Was back in January, there was some research that was published, not by me, but credited it here, where essentially what they found is that there's this obscure method called get federation token that was being used for persistence. And it was interesting because you could use this method to persist, not everywhere, but you could use this method to persist at least in the console UI. But even after the original user account was disabled, you could still persist this way. And so people were, from what I understand, people were using this method to try to survive an eviction and maximize dwell time and try to persist even after people were attempting to evict them and disable the original account and kick them out. They were still. So this was output back in like late January, early February. And I like this example because back in January, back in December, January, this was something that we didn't even really know we needed to look for, which is often the case. The cloud threat actors are still in a period of rapid evolution. And there's new research coming out, and there are new tactics and techniques appearing now and then that sometimes there are things that we didn't necessarily know what we needed to detect. So I like anomaly detection there for that reason, because sometimes it's good at finding emerging threats, even when we don't know what we're looking for. We know we need to be looking for what's next, but we don't know what it looks like, so we can't write a rule or a search for it, but sometimes we can still find it with anomaly detection. So that is my talk, and we have 1 minute left, I think. So I can take maybe one question, but I'm happy to hang out for questions. No questions? Question? One question. Okay, yeah, so the question is, what about time of day? So I think it will be useful. I think what I need to do there, though, is I need to type the users because there's a lot of programmatic users running automation and tooling and doing work in cloud environments. And the programmatic users, they don't have seasons. They're not nocturnal, they're not diurnal, they're just doing work all the time. But for the human users, if I can type the human users, I think looking for anomalous time patterns for them could be useful, yes. And I am at time. Thanks.